Hello, this is a presentation of an ongoing research project, a case study of how we interpret architecture in literary works using VR technology. I tried to develop a workflow by which the multiple interpretations of a piece of text can be translated into a VR-based interactive environment. This workflow as a tool helps readers to enhance their understanding of the literary work by experiencing the VR version. Moreover, this workflow also provides a method of text-generated architecture design tool. My research aims to investigate how we can produce a workflow by which the architecture described in literary works can be interpreted in VR-based environment, and the users are able to experience the virtual space. This workflow sets out from reading to analog interpretation, such as sketches or textual description, and finally to a three-dimensional virtual environment, which allows the users to work around, interact with the objects, and enhance their understanding of the text. When reading about a description of architecture, the reader may unconsciously have an image of that space in mind, even if he or she does not notice it. A term, transportation, called by Richard Garrett, can explain this phenomenon. A name, a sound, or taste described in the text has the potential to transport the reader to that virtual place instantly. As the text brings the readers to the virtual space, some further associations could emerge, such as memory, another read book, or a familiar sound. This is called entrancement by Victor Neil, which describes the reader gets immersed in between text and personal experience. As a result, the understanding of a text forks to multiple interpretations because of the influence of personal experience. My question is how the readers recreate this textual architecture based on the interpretation, and how we can visualize it in VR. Accordingly, the workflow will be the key of my research. Why use VR technology? It enhances the level of immersion and interaction significantly comparing with traditional sketching and modeling. The first image shows a stereographic projection of a 2D digital sketch. The user can rotate the view as if standing in a 3D environment. The second image of VR sketching illustrates how we can sketch in a virtual environment. The third image is a VR-based modeling tool. Designers can use VR technology to create or modify digital models. The last image is Half-Life Alyx. In this video game, the player can interact with almost everything, which provides a deeply immersive experience to the players. As a result, the workflow as a key of my research will examine these forms in different stages. In general, my research overlapped several areas such as research into VR or XR, literature theories, game design, etc. Moreover, researches into film, unbuilt architecture, digital art, and hypertext are also considered as periphery areas. This is the general structure of the workflow. Initially, the research investigates the traditional reading process and collects the reader's interpretations as raw data. In the form of a workshop, a group of readers will read the same excerpt of text and describe their understandings of the textual architecture using analog forms such as sketch and textual description. The interpretations are documented in the questionnaire, and the readers answer questions about how they imagine the architecture in detail. The next stage of the workflow is to use modeling tools and game engine to translate the raw data to VR environment. Meanwhile, The design of user interface aims to simplify the manipulation so that any user can use it with simple skills. It is true that we can hardly translate the reader's thinking accurately. Interpretation in translating stage is inevitable. Therefore, it is essential to test the workflow, and the user can give feedback to suggest how successful the workflow has translated the reader's thinking. Users' feedback will be used to update the workflow, and it also implies how the reader's understanding is enhanced. Initially, I focused on how the collected data can be translated to digital forms and create a virtual environment. I designed a prototype of early stages in the workflow using a pilot case study, which is recreating a demolished home based on a Chinese family's collective memory. In this pilot study, no literary work is used. Memory is regarded as a kind of text. Recalling the memory, or we say reading the memory, causes multiple interpretations because of family members' ages, backgrounds, and experience. Therefore, a place can be described in different results. Moreover, the memory is like a familiar text to the people. Therefore, the interpretations can be limited in the range, and the workflow can focus on setting up the criteria of digitalizing the analog form rather than recreating a large database. Once the valid workflow is created, it will be used to investigate literary work interpretations. As you can see here, this is a timeline of the demolished home. I collected photographs to highlight scenarios during different times. According to the family members' description, 4 generations had lived there for more than 40 years. During that time, that building had been through several significant changes, and 4 generations all have their own unique memory about that place. In some ways, this case study reflects the timeline of a traditional Chinese community as a part of city regeneration and outlines how the traditional Chinese living style was deconstructed and replaced by modern life. This case study has a more detailed workflow. As is mentioned previously, memory here is taken as a familiar text. The family members participate in the workshop and answer the questionnaires about details of the family house. The questionnaire collects not only architectural details, but also encourages the participants to recall emotions and other non-visual feelings. The family members can use either sketch or textual descriptions to recreate the family architecture, and the answers constitute a database, which is translated into digital forms. I used modeling tools such as SketchUp to rebuild the architecture space and surrounding environment. Game engine like Unity 3D is used to improve the quality of digital models and to apply other effects. Regarding the level of interaction, the users can walk freely in the VE in the first-person view and do some simple interaction with some objects. The final product is a screen-based VR because the family members are in China. Sending this kind of format is easier for them to use. After experiencing the virtual environment, they will give feedback about the experience in the VE. The workflow uses the feedback to further update the system. Although not all the family members are familiar with hand drawing, I have collected some interesting sketches with annotations. For example, the first image shows the interior space in the 1990s. It was a crowded and messy place. The second image is a description of the house as a family sewing workshop. The atmosphere seems not that depressing. The third image is a plan showing the house in childhood. Everything was huge from a child's eyes. All these descriptions have sketched out a whole image of this demolished building. These sketches are not purely objective observations. They describe the space with subjective impressions and the atmosphere. That makes the answers diverse. The next stage is translating the answers to digital forms. I used modeling tools to recreate the architecture space with mentioned details. It is true that not all the answers include plenty of content. Insufficient detail could lead to second interpretation of the questionnaire. Therefore, some initial feedback and supplement of details are essential to the workflow. Moreover, because this building has different appearance according to the descriptions, the virtual environment has 3 themes representing 3 different times. As for the atmosphere and emotions, multisensory experience is the key trigger for evoking that feeling. Unity 3D as a main tool merges architectural models and other effects such as sound, lighting, and particles, etc. In this slide, it shows how the building looks in the 1960s. This screen-based VR has been presented to the family members and got feedback from them. Here's an example of how the workflow responses to the feedback. On the left, we can see that we have got several comments. The right image shows that the workflow returns to the previous stages to amend the model and VE. To sum up, this prototype has created a feasible workflow from memory to VR-based representation. Another case study of literary work will push the workflow to later stages, especially enhance the level of interaction and openness to the users. Ideally, they can directly manipulate the system to create the interpretations rather than using analog forms. This is a detailed workflow of how a literary work can be translated into VR-based interpretations. I chose Umberto Eco's novel The Name of the Rose as the objective text. In order to identify a broad range of interpretations, I have conducted 3 workshops involving architecture students from the first year to the second year. The collected data were categorized and translated to digital forms, generating a model database for building the VE. The design of user interface aims to allow the users to choose from the database and construct in the VE so that they can create architecture space rather than experiencing an existing architecture space. Therefore, the workflow will have the potential to represent multiple interpretations created by the users. A testing stage will assess the workflow regarding its performance and quality of virtual environment and user interface. Print text is different from memory because the readers can spend more time on analyzing the text to extract relevant information for interpretation. For example, the participants can highlight the text with different colors to identify different kinds of information, such as architecture plan, material, size, atmosphere, and sound, etc. Therefore, the interpretation as sketches and textual descriptions are categorized and documented so that the database is prepared to be translated into digital forms. These are the architecture plans drawn by the participants after reading a description about how the characters walked through the building. The participants will speculate and design the plan according to the text. We have collected more than 50 different interpretations of the plans, even though they have some similarities. For example, when the text clearly mentions the shape of the rooms, there will be no space for interpretation. Therefore, we can see that almost all the interpretations have that heptagonal for a room. However, there's no clue for the size of the room, and the description of the spatial sequence is confusing. That is why the plans are still diverse. Apart from the plan, the study also collected all kinds of windows, tables, bookcases, etc. Moreover, the participants also have different interpretations of unmentioned but relevant qualities such as sound, weather, and atmosphere. As you can see, the interpretations categorize and visualize as architectural elements, objects in room, and other qualities such as sound and lighting, etc. In order to link the objects to the original text, the user can also interact with the objects to see the description or relevant plots. The previous pilot case has created a feasible workflow from text to a virtual environment. This case study focuses more on the design of user interface to enhance the level of interaction and openness. Also, my strategy is that the UI should be intuitive to use so that every reader gets the chance to read the book in a different way. This is a mock-up sketch for the design of UI. It suggests how the interface looks. Moreover, to get a further involvement, I have designed 3 types of interaction: construction system, control system, and note system. This is the construction system. The users can control the first-person character and walk in the environment. He or she can choose and place an architectural component or interior objects in the VE. The components can automatically attach so that the users can build a consistent floor, ceiling, or wall. Thus, they can freely create the layout of the architecture. The second system helps the users to modify the size of architectural components. As is mentioned before, although the rooms might have similar shapes, the size cannot be the same. The users can drag the handles to control the size of the components as they like. The third system is called Note System. The user in the VE can click the interactive objects to acquire further information such as the story behind a piece of painting, a brief history of the book, or other readers' interpretation of an architectural component. In the future, it may allow other users to input new notes to the system to improve the level of interaction further. In conclusion, these 3 UI systems encourage the users to get a deeper immersion into the VR environment by increasing the level of interaction and providing more information to the users. With the UI and interaction systems, the workflow can be used to create multiple interpretations of the textual architecture. These are 3 samples of different spatial sequences according to the text. The user's creation can be saved for further analysis and comparison. In the following updates, the users can also change the material of the component. As the study collects more data, the user will have a larger number of choices and more types of interactions. In conclusion, the structure of workflow from text to VR-based interpretation is set up. According to the pilot case, secondary interpretation in translation stage is inevitable. There is always a gap between imagination and visualization, but the feedback can help the workflow to develop the virtual environment or the UI to fill in the gap gradually. As for the future work, the workflow will be used to test if this is also feasible in interpreting other literary works, it will continue adding more options and functions to the users. Due to COVID-19, the study came across some difficulties in testing the VR. Accordingly, the research is to use a screen-based VR as a game-like application for remote testing instead. Thank you for listening.